In this problem, we're asked to find the value returned by analog read 3 for the circuit that's shown to the right. The way I'd start working this problem would be to write the information given from the problem statement into the circuit diagram. We know that the photoresistor has a 20,000 ohm resistance. Keeping in mind that we're trying to find the value returned by analog read 3, we need to look at that circuit and identify how we can find that analog value. Remember, the analog value is analogous to the voltage drop across the components between the point where the analog pin is connected and ground. So in order to find the analog value, we need to find the voltage drop across the 10 kilo ohm resistor. Once we find the voltage drop across the 10 kilo ohm resistor, we can then find the value returned by analog read 3. In order to find the voltage drop across the 10 kilo ohm resistor, we have to find the current that passes through that 10 kilo ohm resistor. Knowing that the photoresistor and the 10 kilo ohm resistor are in series with one another, we can say the current passing through the photoresistor and the 10 kilo ohm resistor is the same. We also know that because the circuit is connected to a 5 volt source, the voltage drop across both of the components is 5 volts. That 5 volts will be divided between the photoresistor and the 10 kilo ohm resistor. Knowing that the photoresistor and the 10 kilo ohm resistor are in series with one another, we can add them up to find the equivalent resistance. And we know the voltage drop across the two components together is 5 volts. We can find the current that passes through them. Finding the equivalent resistance is simple because they are in series and we just add them together. So if 20,000 ohms plus 10,000 ohms gives us 30,000 ohms. If I redraw that circuit, it will look like this. And remember, the voltage drop across that 30 ohm resistor has to be 5 volts because the rise have to balance the drops. Now we can find the current that passes through that 30,000 ohm equivalent resistance, which will be the same as the current that passes through the 20,000 ohm photoresistor and the 10,000 kilo ohm resistor. So utilizing Ohm's law, we can say current is equal to the voltage drop across the equivalent resistance divided by that equivalent resistance. That voltage drop is 5 volts and the equivalent resistance is 30,000 ohms. That gives us a current of 0.000167 amps. Now that we know the current that passes through the 10 kilo ohm resistor, we can find the voltage drop across that 10 kilo ohm resistor. The voltage drop across the 10 kilo ohm resistor is equal to the current of the 10 kilo ohm resistor times the resistance of the 10 kilo ohm resistor. So that's 0.000167 amps times 10,000 ohms, which is a voltage drop of 1.67 volts. Now, using our proportion, we can take that voltage drop and convert it to an analog value. Our analog value will be equal to 1.67 volts divided by 5 volts times 1023. That gives us an analog value of 341, which is answer D from our answer choices. The critical thing when working these problems is knowing that this analog value is related to the voltage drop across the components between the point where that analog pin is connected and ground. Once you know that, you can apply all the things that you've learned previously in this class about how circuits work when they're in series or parallel, Kirchhoff's current law, Kirchhoff's voltage law, and Ohm's law to find various components in order to answer the problem.